For assignment 2, then, we're going to be doing the same types of operations. And get to the cookbook portion of the introductory material. We're going to be following these same kinds of strategies. Face and establish our Z. Run around the perimeter and establish our contour or outside shape. We're going to ask the same types of questions. How many? What is the material? This says aluminum. Maybe the next one we'll switch over to a steel or a stainless steel just so we can see the adjustments in the feeds and speeds. We all like to run in Delrin and aluminum, and not every part is up to that. So, a couple other choices just looking at this part is we're 5 inches by 5 inches. That's a pretty good sized part. Right? So when I'm thinking about this piece, is this going to be close enough? If we buy a piece of material that is 5 by 3 in bar stock and we cut as many out of it as we can get, and the 5-inch width is probably what 15, maybe at least 10 thousandths, maybe 20 thousandths oversize on the raw stock. I'm not just going to be able to blow this around. If it's steel, can probably count on it being 5 to 10 thousandths undersize, right? So at that point, I'm not going to be able to, I may still be within my tolerance zone, but I have to adjust to what the stock sizes are going to be. All right, so I think when I ran this previous, we kind of just looked at it as, oh, we could square this up offline, but I'm not really, getting very efficient with the geometry. So I think I have some either 4-inch or at least the 3-inch material that I could go get a rough number, but there might be enough. And the 3-inch depth, I don't know that I'm going to be able to go all the way around and down. The other thing is, if I did half of this, 1.5 inch depth with the 1 inch to the base, and then turn it over, then I'm almost guaranteed to have a slight mismatch. Is that going to be acceptable? It's going to be within the 5 thousandths tolerance, but there's going to be a definite witness line that I probably just can't turn this thing over. So at that point, then, am I squaring it up, manual operation, or setting it up to square it up to 5 by 5 by 3 in some other setting? Or are we getting oversized material? Because once we get large enough, I look at the material order and I can see that I'm probably not going to find a 3 1/4. I'm probably going to have to jump right up to a 3 1/2. And then, at that point, wow, that sacrificial material, I'm taking a lot of sacrificial material off of the bottom of this. So we have those decisions we have to make. At 5 inches, even with a 2.5 or 3-inch face mill or fly cut, I'm going to have to go back and forth across this, at least make 2 passes over it to clean up the whole surface. All right, so again, going through that process, going through your thought process, making decisions, knowing what tooling you have in the shop and what combinations are going to give you the best, quickest results. If I'm making 10 of these, I'm less concerned about finding those minutes and seconds. I got to get these done. If I'm going up to 100, I'm a little more concerned. 1,000, I'm a lot more concerned. If we're going to run these for quite a while, then we're going to get very efficient on the program throughout 3 or 4 iterations as we build it in. I'm not expecting my first go to be the perfect program. My goal is to get a program to the machine, the tools set up, see what works, what doesn't, and respond, observe and respond. Make sure that we're getting the results and parts coming off the machine, so that I can find those efficiencies, I can find those little tweaks and changes to make it better as we go. All right, so things to look at. Again, the 5 by 5 by 3. If we're holding on to this in the standard 6-inch vise, that's going to be fine. I may go in and go ahead and go the 5-inch width, whatever my saw cut is. Take a little fly cut, get it close enough. Make sure that there's no perpendicularities, there's no datum callouts that are really tight controls that we're going to have to contend with as we go through the machining process. So that's going to drive some of our geometry. The other thing would be, can I hang this off and machine the one side. Well, now we're talking about a 3-inch cutter. All right, 3-inch length of cut. I'm injecting more harmonic, more vibration into that part, and if it's a rough saw cut, how much am I going to oversize it to make sure that I don't end up cutting, these nice little trapezoids that don't clean up? And that's a big chunk of material to have pieces not clean up and go into scrap. All right, so all of these things that we're going into process into the programming, and that conversation inside my head maybe takes 30 seconds. I'm going to do this. I'm going to do this. I'm making a decision, and then we start going from there. All right, so through all that, I didn't get Mastercam started. All right, so what else on this? We've got the 4 holes. They are 1/2 inch, 2 inches deep, and the pocket at 2-inch diameter. So same types of strategies. If you prefer to draw in quadrant 4, then we're just going to do that shift and make the math work. If you draw around the center point, I'm still going to say we're going to shift that origin over to the corner. Ergonomics, practice, whatever you want to call it. Unless I have a really odd shape mold base that is going to be a problem, I'm probably not finding centers. Yes?
So if you drew it on center, you just do a translate?
Yeah, it's a move to origin or translate from point to the new point. And so one of the things I say in SolidWorks all the time is draw for convenience, and then when you come up, or I'll spit it out, design for convenience, detail for manufacture. We're going to draw this as conveniently as possible, as quick as possible, making sure that we have the geometry pretty much like what's shown on the screen. When we come down to the programming, we're thinking about where our work offsets, where our best coordinates are going to be, and work from there. All right, so kind of the industry standards, what we do in the shop. If everything gets touched off to the center of the part, great. That's where we'll leave it. But I don't know many shops that consistently go back to the center of the geometry. So the other thing with this is the newer version. So we talked a little bit about the differences between the 2018 on the class computer versus the 2020 that you're going to see on your downloads. And there are a few minor differences, but in industry, you're also going to have all the way back to Mastercam X or X3 or anywhere in that range, depending on how the company updates and supports their subscription. So since one of the first things we did was talk about the tool crib and the list, when we go over, I'm going to go back to utilizing that tool crib so we can kind of start down that path. If you haven't set up the tool crib, just add the tools as you go. Realize that we're going to kind of modify and build in and make that tool crib a little more functional. All right, so our drawing, we're into the wireframe. And if I go to the shift gears here, so we had the lines. I know it's right in front of me. That's what I get for talking too long. Yep, right in front of me. All right, we go into the rectangle. I'm going to anchor to the center. And 5 by 5. All right, so at this point I haven't locked those numbers. So when I come out, if we click and I accept by hitting enter, I can have it go right back to. If I start moving the mouse around though, that rectangle is we're going to see those numbers start to adjust accordingly. So let's see if I can get that one. So we'll come back to the center, and as I start dragging, since it's not locked, as soon as I start moving the mouse, that's when I'm going to see those numbers start to change. If we wanted to draw nothing but 5 by 5 rectangles, then I would put in the 5, hit the little lock symbols, and I could keep drawing those rectangles. All right, so that gives me my starting envelope. The hole locations. So we have a 1.6 and a 1.6 for the small hole. So we'll go to the circle. And then I'll do the two, and then we'll run through the mirror. We could also do the circular pattern. It's kind of a toss up. One of them is going to make more sense to you. I think mirroring across the axis is probably makes more sense unless you have a bolt circle or something where you're wanting to do the transform rotate. We'll probably stay with the mirror. All right, so our diameter goes to 1/2 an inch, and I do want to lock that in place. And then we come out, and my little box up here that kind of went up into the ribbon, I'm going to start typing 1.6. Well, let's see if it'll let me have it. There we go, 1.6, comma 1.6. So it takes a little bit to get that engaged, and then it shows up in it's showing up better on the screen than it is on my screen with the cyan. Right, and then we can go over, and the next one will be 1.6, comma minus 1.6, setting up those coordinates. Oh, and since I didn't hit the checkbox, it didn't finish anyway. So 1.6, negative 1.6. Either that or I did negative 16 on that one.
I think you missed a decimal, yeah. Might be on there way negative.
Yep. All right, so that one looks good. Make sure to hit the checks. And then we'll go ahead and get out of it. And I want to zoom to fit. And sure enough, there it is when I zoom out. So at that point, we'll just highlight it. Don't know what it picked up. I wasn't in line, was I? Gee whiz. Okay, not sure where that one came from. All right. Well, since I managed to hit Control Z thinking that I drew something there, I still don't know what I drew. So let's go back over the modify since I managed to undo that. I want to hit F4 on the keyboard, or right-click and do the entity properties. When we have the entity properties, since this was a simple mistake, I can go back and type it in as 1.6 minus 1.6, and when I hit enter, it jumps up to the proper location. We go ahead and hit OK. Then I'm going to right-click and hit fit again and figure out what that is on my screen, because
I think it's your Z-axis. I think you're a little skewed.
I managed to hit the button. Thank you. All right, Alt-1. All right, so yeah, we got those. All right, so I'm going to try and do the pre-select because that's kind of my preferred strategy. If I click and click and then we go into the transform, then I should be able to mirror, right? Because they were pre-selected, it goes right in, and I'm telling it to make a copy, and we're going across the y-axis. So we give it the y-axis, and it will show us the location. So when it was in x-axis, pretty much it was making duplicates, flipping them on top of each other, so I don't see any net result. When I go to y, we're going left to right over the y-axis. So another one of those little, I know it's doing something, I'm just not sure what it's doing. All right, so at that point, I can come back over to the home and do clear colors, or we right-click and clear colors and put everything back into that normal, our normal color, wireframe color. All right, so one more circle, and then we'll talk about the fillets. So a diameter of 2 inch. And I did put that in the diameter, didn't I? I already put that in the radius. All right, so we get to modify those anyway. All right, so let's make another modification. I'm going to select all 4 and then go to F4. All right, and all of them are in the position, so the radius was not 0.5, it would have been 0.25. And I'm just enough off screen that I may not be able to get that. Nope. Well, I saw it do it, and then I didn't have the checkbox. So try one more time just in case. So that's a propagate. No, that wasn't what I wanted. Now let's see if we go to the right and analyze entity properties. So my screen resolution is just low enough that I'm not able to get off of that screen. So let's go 0.5, enter, enter. And then I'm going to pause for a second and see if I can resume. We'll try it at 1600 by 900. One more time. Select, select, select. And then F4. 0.5, and then now I can see my checkbox, and it only did the one. So I think that was where I needed to do the propagate. So we'll just stay in it. Go ahead and I'm hitting the tab button in between, or the enter button, to get it to accept it. Okay, so that was the long way to get those. I probably could have redrawn them faster. The minor issue with the screen resolution. All right, so circle. We're at the 2-inch diameter. Make sure I put it in the right one this time. Pick at the origin and then accept. All right, so the last one with the fillets to get our geometry. We're going to go into the fillet entities. And we want to uncheck the trim entities, right? Because that lower section, if we go all the way around, we're going to keep that that geometry. So our fillet was 0.75. I've got two of them in there. And then when we pick, we're going to see it come up. I saw the preview there. So we pick and pick. And I'm used to SolidWorks where I go right to the corner and then it puts the fillet in. But we're going to do the select and the select, and that's going to give us the geometry. All right. So at this point we have I believe we have everything. So we come back over to the transform. We do the move to origin is going to be easiest because in most cases it's going to pick up all of the geometry. So I do a move translate from. Well, let's get the tooltip out of the way. And then when I pick on that corner, it drives it all the way into quadrant 4 so that I'm ready to start the machine operations. We'll clear the colors and zoom to fit, which should also be under view since I'm getting into the right mouse button. So if I go to view and to fit, that will have the same result. All right, so questions up to this point? So this may be another one since the 1/2 inch, 2 inches deep doesn't really do all that much. Maybe we'll make that a 1/2 13 or a 1/2 20 tap, and that'll be optional. All right, so if you want to put that in there or work with it, you know, adding a few more operations. Occasionally, you know, either that or maybe a ream since we tapped last time. We'll make it a 500 plus or minus 1/2 thou or something. I don't know. All right, so we come back over to the machine. We're going to pick our default, and that's going to set us into the properties. And even though I'm not really changing anything on the files, I'm still going to look down through here, anything that I would want to check. We load up the Haas controller at some point, and I have to go back and update these. This is where I'm going to edit or replace that control. All right, so we can go ahead and program this out, and then if I have 3 different machines on the floor that have the potential to run this, as long as I'm kind of planning on the eventuality that my typical strategy is I'm going to pick the machine with the highest RPM. and then I will be able to back off. Right, so
Okay. Where do we get the properties at on that one?
So once you select the machine and you come over, let's go ahead and let's go ahead and accept that. When you go to the machine,
Yep.
and you pick the mill,
Yep.
and you pick the default,
Default.
and we're gonna add that
Mine's blank.
that Haas control.
Yeah, mine's blank now. This is the one that keeps
Oh no.
Yeah.
Okay, so we're gonna have to check that one out. You should have if you don't have the properties. So yeah, that would be the other one is if you are in plain solids, any of the other tabs on the bottom left, then you want to make sure you're in toolpaths. There's only a couple. I think the solids and that prep that come up blank. So we'll get those in. All right, so back over to the toolpaths tab, and then we can pick our files. Come over to the tool settings, and one of the things that I always have to, those settings that you make once a year, and then next time you have to do it, you have to fumble through it again because you're not going to do it for another year. Inside of the control, I can go in and set these defaults, so I don't have to check. I don't have to change the program number from 0 to 1. We're going to assign tool numbers. We're going to warn of duplicates, and I don't like the 100, and a lot of times I will turn those off. So the feed calculation set from the tool, the material from defaults, user defined. We're going to start to look at those a little bit more, and then when we come to the material, again, these are where it's pulling some of those numbers if we edit. Pretty much all I'm doing right now is a placeholder. So when I go to select, I'm looking for it to pull up the mill library, and we're going to find our 6061 aluminum, and that changes it over. So if I was running steel, if I was running plastic, I can go ahead and add those materials. And then the stock setup, we have 5 inches in Y, 5 inches in X, 3 inches in Z. This is going to stay an absolute number. And then I want to take those two numbers and divide them in half. So 2.5. And then also I'm shifting this off of the origin into the center of the part. When we start working in the wireframes, or yeah, maybe this is a good time to do it. We'll go minus 2.5, and I'll see if I can get the decimal in there this time. All right, so if I go 2.5 minus 2.5, that shifts the stock center over to where I've drawn the part in quadrant 4. So the other option, since we haven't I do want to turn on the display and make sure it's in wireframe. The one thing with the solid is the solid shows up in whatever color you've selected in the origin. The default is red, and it's pretty overpowering. So solid is nice up to an extent, but it's kind of a pain too. All right, so our other option would be to select the corners. We don't really have a bounding box, surfaces, all solids, all entities. So if I go with the select corners, then one corner will be the origin and the opposite corner, and it shows me the exact same thing. All right, so if I have that available, if I'm on the envelope, then I'll utilize that. I'll go ahead and hit OK. All right, so it's time to decide what I was going to do with the 5x5. So if we find the stock in 5 by 3.25, 3.5, then we're going to still use the sacrificial material. If I need to do this as a separate, then I'm going to have a first operation that's going to kind of square this up so I can just deal with the radiuses. All right, so if we go around, 3-inch length of cut, carbide tool, running even on the light duty machine is going to, it's going to be a little bit of hogging to take that material. All right, so if I overcut this by maybe 1/8 of an inch, it means it's going to be fairly light across the backside, fairly light across the front, and then both sides will have somewhere between 40 and 60 thousandths of material to remove. All right, so the can't say that I'm gonna be able to take that all in one contour, but I should be able to either do the ramp or the step and repeat as a rough, and then when I bring it back to finish, we can work around it. All right, so the other thing I brought up was the facing operation. We're always establishing our Z face. When I touch off the tools, then at the control, I'm going to send this down 10 to 20 thousandths and clean up the material across the top. So if we come up to the facing operation or right click over in the tree, then I'll see the mill tool pass and go to face. And a little bit different than what we saw in 2018. So everything's still there. The chain method, the partial chain, but with the face, it still says you picked a stock. You're probably going to face the entire stock. So all I really need to do is hit OK. So when we look at this, select OK to use define stock or select chain 1. So chain 1 would be something along the lines of let's just reverse this for a second. Hypothetically, this is a boss, and I don't really care about the rest of this material. It's going to be an open pocket, or we're going to do something to remove all that material instead of making it a pocket. In that case, I would just want to run back and forth across this face. I could select that circle as a chain, and it would only do that material. All right. So if I don't need the whole face, I can pick a portion of it. One of the other examples is when we do the steps. All of this material is going to be removed, and we're just really looking to machine across the portion that is going to be remaining. And so you can make those decisions. Go ahead and hit OK. And we'll start to see what's changed between our 2018 and our 2020. So the tool. Now, one of the things I didn't do was pull up the library, and I don't know that I put a face mill in there anyway. So let's go ahead to the library. And since we are going to pick up the other one, let's that one's saying a new library. So that means I need to go back to the manager to get to mine. Let's see, we still have the filter. Okay, so I picked a 2-inch face mill. Let's go ahead and see if it will accept that. All right, so it picked up the basics. Tool pass. Let's just take a real quick look at the tool manager. All right, so this is the view that I'm more looking for. And when I select a different tool library, hopefully it goes and it finds mine. Mill inch. Okay, and since it's been a couple weeks now, I have to remember where I put it. So Mastercam. Now it's going to be in the documents. All right, so we set this up for the TM tools to be for aluminum, and when I open, now I have the 1/2 inch. I have the 3-inch face mill that I created. So let's go ahead and we'll delete that tool. It says it's used by one operation. I already have kind of a dirty operation there, so we're going to be able to select for that one. I'll just go ahead and clear it out. Double clicking on the parameters, we go back to the library tool. I pick my 3-inch face mill, and again, if you haven't set up your tool library, just go ahead and accept the 2-inch, and we'll add it into the mix. Start building this out. If you have your library saved to the USB or to your file, then we'll go ahead and utilize that. All right, so either way is going to work. All right, so 3-inch face mill. I haven't put any values into that tool. So one of the things, if I double click, that's going to take me into that tool definition. So we have the cutter diameter 3-inch, cutter length, chamfers. All right, probably would have. That'd be about right. shoulder length, upper diameter, finalizing the properties. Coming in as tool 1, surface feet per minute at 1,000. Well, we said that okay, so number of flutes is 4, feed per tooth is 4,000. Not sure where it picked up the 50 as a repeat. All right, so that still seems a little bit fast. 1286 at 20 inches a minute, and then I'm not real fond of having all those decimals, so let's see, 4 flutes. Slow that down just a little bit. We don't want to plunge, but we can ramp, and we'll just bring that one up a little bit. Okay. Now, one thing to notice is it really didn't change. So hopefully, when we encounter that again, it will update these numbers for us. So since we came up with feed rate of 16 and the spindle speed was 1300 RPM, plunge rate at 16, and then like I said, I haven't been in the habit of using the comments, but this is where we could go in and do a face to write into the code. All right, so I'm not too concerned with the holders at this point. Cut parameters, right now we're set to one way. Let's go to zigzag. We'll just have it feed off and come around. And again, I'm not so concerned about memorizing whatever one of these does. The cross overlap, how much is going to step off to the side. The long overlap, how much is going to feed off the end. The approach distance, a little bit extra so that we're not gouging into that extra material, that saw cut material. So the approach distance and the exit distance. We're going to see those on the toolpath. So if you don't remember or you don't have a real good feel of what those are doing, we're just going to observe the result. And then a max step over of 75% or 2 1/4 inches. That should be pretty good. And then stock to leave on the floor goes to 0. Most everything is going to be tip comp. And then roll cutters around the corner sharp. We're not doing anything there. Don't really care if it's an even number of passes. And then auto angle is going to be to 0 degrees, so left to right. And then if I change it for the move between cuts, then we can go to the loops, the linear, the rapid, or leave it to where it'll just do the arcs. Depth cuts, we're not stepping down, removing that material. When we flip this over to remove that that sacrificial material in a second operation, then I may use this tool again, and I know that the depth of cut on the insert may only be 100 thousandths, 150 thousandths. So then I can set those depths, and I know that I have to remove somewhere around, a 1/4 of an inch or so. Then we can take it in a couple of passes with the depth of cuts. All right, so for our next couple of programs, we're going to stay with the absolutes. And 1/4 of an inch. So on this one, I'm not worried too much. I'm going to stay with my standards. 1 inch, 0.1. Top of stock is 0. Depth of cut is going to be the top face, so it's also 0. All right, and then home and reference points we're not really dealing with here. The coolant, if we want to set coolant, we can set that with the tool. Or come over and just turn one of those on. Okay, we'll go ahead and hit OK. And we still have the dirty operations, so I need to regenerate. And so we're seeing that linear. I would like it to be the arc. So let's see what it looks like with rapid. All right, so it comes over, steps down. All right, but that is going to be a rapid move. If we're still engaged in the part, if If we didn't account for much, that's going to come down and be a very exciting transition. And then the high-speed loops. All right. So it feeds off, makes the arc. Again, it's not having to stop, change directions. You know, even at 16 inches a minute, that arc is going to be smoother transition than coming up, making a 90-degree turn, or coming up and going into rapid to the next position. All right. So to rough, I think let's see, for the 3-inch deep, we need a fairly long tool. So we're going to go into the contour. So mill tool pass, I'm on the right mouse button again. Or we come up to the ribbon and pick contour. And I think it's more just habit that I like the prefer and like the right mouse button. I want to do partial, mainly because with these arcs, it's going to come to that that transition, see that there might be a branch there, and then ask me anyway. So if I pick a direction, select intersecting entities. Now that's oh, they did change it. Well, never mind. Yes, I do want to keep the operation. No, I do want to stay with that. All right, so if I keep the operation, then what I was looking for was partial change. I'm falling into the 2018 to 2020 trap of partial used to be where the vector was. At least I'll have to check. My memory says it is. All right, so the first entity on a partial is there. It shows me the direction. I pick the next. I pick the next. It reversed on me, so I don't like that one. And then we want to unselect. And it did it to me again. So I'm picking a little bit closer, and then we'll pick a little bit closer, and that comes off. All right, so I go ahead and hit OK. I'm still going to come back and select the chain. I still got 2 chains. So something in there, whatever I picked, was not complete. So if I highlight the chain and hit delete on the keyboard, well, let's go ahead and rechain it. I'll just go ahead and get rid of both of them. And I want to rechain all. So let's see if the all the way around will work. Select an entity to start a new chain or modify the active chain. Well, I guess we're going to see what it does. All right, so my outside perimeter is lighting up. That gives me a desired result. As far as direction, we're going to be climb cutting, and we're to the outside of the part. So I can verify that geometry. And so again, that was just on the toolpath type, coming over to the chain geometry, and being able to work inside of that group. So on my library tools, and those came over with the defaults. All right. So typically I would want, all right, so I still have to modify my my library since I retained those. And I don't have the three-quarter inch tool that I'm going to be able to get that 3-inch length of cut with anyway. All right, we'll go into the filter, make sure it's set to none, and then I'll make the corrections as I go. All right, so in mill flat, we accept it. Since I'm still in my library and I haven't created one, I don't get one. So we have to navigate back to the tool manager because I'm still expecting to see that lower group there. So the 3-inch actually should have been tool 1. Oh, that did come up tool 1. My bad. All right. All right, so let's see if I can find my way back. So, since I don't see the public documents, if I'm remembering this correct, we have the shared, and then the mill and the tools, and that takes me to the tool library. So knowing where some of these folders are and being able to navigate, or picking up the folders that you use all the time and putting them in a more convenient location would be a pretty good idea. All right, so back to the mill inch tool library, and then now I can get back to the filters. So we're going to work back and forth a little bit on those. So none, in mill, okay. Make sure that my filter is active, and we're going to pick a 3/4 inch flat and add it to the group. So the drill bit and the ream we should be able to get to. All right, come back to the parameters. Have the tool now. I didn't set anything as far as the speeds and feeds on that one. So even on the TM, I'm probably going to run that at 4,000. And the feed rate, if I was on a more rigid machine, probably would be about 30 to 40 inches a minute. We'll drop that down to 20, and I'll leave the plunge rate at 20, and we'll go to rapid retract. So this will be my roughing pass, except my caps are on, so let's get that in place. All right, still not concerned with the holder and collisions and whatnot. One thing with the tool though, because it's a 3-inch length of cut, we're basically going with an extended length. When I look at this tool, overall length 375, cutting length of 2 inches. When we go over the simulation, it's going to see that 2 inches and say, oh, you're going 3 inches deep. I can't really do that. So let's go up to 475, and I'll make this to be 3 inches. Now that might be right on the edge, but at least in the simulation it has less of a chance of picking up that geometry. All right, and then we'll finish. And that didn't change, so we should be good there. I'm going to go ahead and add that, apply that to the mix. And then the cut parameters, since we're in the computer, it's going to calculate tool center line, but it's not going to engage the G41, G42 compensation. So one less line of code really, but stock to leave on the walls, let's go 10 thousandths. And so if our 5-inch material isn't that much oversized, or it has a little bit of taper to it, we may not see it clean anything on the front or back as it makes this pass. Let's see, contour type is 2D. Radiuses, external corner radiuses, yeah, well, those look good. I think we're going to go with the ramp. All right, so the lead in, I don't really care about the midpoint too much. Let's start off on the corner. And with the square, I still like to just go ahead and adjust the start of the contour. And we'll go out at least the 0.75. Let's see, that's diameter. So the radius would be, let's go out about 1/2 inch. And we want to extend it. If it's set to shorten, it's going to be inside of our chain, not going to the outside of the chain. So I'm going to send that over to the adjust end of contour so that those match up. And then we'll see what we get. Breakthrough amount, want to go a little bit past, so maybe 20 thousandths to make sure when I machine the material off of the backside that I'm not going to be going right to that edge, leaving that little bit of aluminum foil, that little bit of material. Multi-passes, again, starting from a much larger piece and working our way in. And then the linking parameters, let's stay with the 1 inch. Our depth is -3. and I want to set those to absolutes. All right, so the 3-inch makes sense for the print. The breakthrough amount, that extra 20 thousandths, runs past that that depth just a little bit. All right, so we're going to look at that one first, and I'm going to go ahead and hide the facing or just turn off the display. So when I toggle the display, it moves over, and we're going to regenerate the video operation. So we have the extension, but it's only making one pass around with 10 thousandths off. Still going to have a lot of tool deflection. Instead, heavier on the ends, lighter on the centers. So we come back over, look at the cut parameters, and then this is where I'm going to pick up the ramp. All right. So when we use the contour type ramp, we can either set the angle, set the depths, or with the plunge. So 3 degrees. Let's see what 10 degrees looks like. I don't want to watch it make paths around this thing forever, but I'd also would like to keep the tool engaged and not do the step and repeats. So one-way ramping, well, it's not an open contour. Linearized helixes, we shouldn't have any helixes, so let's go ahead and see what that looks like. All right, 10 degrees is a little aggressive, so maybe not that much. All right, so I make 2 or 3 passes, make sure it makes a complete pass at the bottom so that we don't end up with that extra material in the ramp. All right. So again, the whole purpose of the ramp, or my preference for ramps, is that when we do step and repeat, it comes down, it engages, it feeds off, it goes to the next, feeds off and re-engages. So we're kind of loading and unloading. Once we get this tool engaged in the part, it's going to stay consistently loaded throughout the entire tool path, or at least reasonably with the same amount of load. All right, I want to repeat, so we're going to copy, and then I'm going to paste. And then going back to the parameters, stay with that tool. The ramp goes back to a 2D. Let's see, one I wanted to check. Well, we'll see what it does on the 2D. Maybe I'll pick it up here. Lead in. Still looks good. Breakthrough amount still looks good. Linking parameters should still be good. And we'll go ahead and accept it. All right, and if I go back to I'll go back to Alt-1, so I see the top. I think that's what I forgot to turn off. Yep, the stock to leave on the walls goes to 0. And if I don't see that little, well, it's still a pretty big part. If I don't see that little bit of separation between the first and the second, then that's usually an indicator that I forgot to go back and adjust. Okay, so that gets us around the part, gets us a cleanup pass, spring pass. We still have to contend with the arcs, and now I'm gonna go back to that partial chain and pick it up. All right, so mill tool path, contour, and we want the partial so that I can do the first, and then that pretty much was the last entity. Nope, I think I clicked too soon. First, and then let's see, what did they change the next to? All right, so if I end that chain, and then we go to chain 2, and then end chain, and go, and end chain, and go, I'm going to be able to pick just those entities. All right, so after we made the selection, then we're going to go right back into the chain geometry. Arrows look good, directions look good. I don't really need to worry about gouging into the corners. They were all cut with the same tool, so I shouldn't have any compensation issues or overlap issues. Being that it's 1 inch deep and it is still a pretty good amount of material, we might do that in 2 steps. All right, so we can use the depth of cut on this one. All right, go back and make sure the tool is selected. We got the 4,000, the 20 from last time. Let's see, probably since I copied, the other one still says rough, so I would probably want to go back and finish. And that may be why I bypass a lot of the comments, is because I end up confusing myself a little bit. Let's go with the corners. And the cut parameter, still a 2D. So if we treat this as the rough, we need the 10,000ths on the wall. Depth of cuts, well, let's make it, if I went 340, that would do 3 passes, but that keeps me at about, let's see, depth to diameter, that's about not quite 50% depth to diameter. Yeah, we'll try it. All right, lead in, lead out. I don't really want to adjust the start of contours anymore. That linear move would bring it right down the edge, and I don't want to buzz that that face as I'm building it in. So we're going to switch the entity and the entry and the exits back on, and the length 0.75, a little bit long. Let's try 200 for the length. Actually, I don't think it needs to be that much. I'm thinking of the radius. So if we go like 50 thousandths off the wall, and the radius goes down to 200 with about a 45 degree, and then we sweep it or send it to the other side. What I'm looking for is that it comes down kind of close to the material and is more tangential. Instead of coming in at a hard angle, it starts a little bit further out, comes in, feeds off, and then picks up and goes back. All right, so the breakthrough amount, not going to help us there. The depth cuts, that was the one we need. And then this one would be very careful with the keep tool down, especially since I gave it the 45 degrees. So let's see what that one does. But I'm gonna turn that one on for the example. I would recommend you don't, and then well, I'll come back and turn it off and explain why. All right, multi-passes, we don't need to step in. We're not doing anything with the tabs. Linking parameters, 1 inch, 200, and the depth is minus 1 inch. And everything's set to absolute. Don't care about the coolant right now. Let's go ahead and take a look what it ends up. All right, so the feed off and then keeping the tool down, it now makes my arc a chamfer, and more than likely, no, that looks like it's staying in the feed. I'm not seeing it rapid. If that turned yellow, I would be even more concerned because it would be rapiding back through the part. All right, so when we're reading this, those lines give me a lot of valuable information that I really didn't want to do that. All right, so we come back, go find the depth of cut, make sure the keep tool down is turned off, regenerate the dirty operation. All right, so now it's going to lift up, and that is going up to the clearance, which I don't think I need to do that. So let's check the lead in, lead out, or the linking parameters. So retract plane, feed plane. Well, I could lower the retract or turn it off. So if I uncheck the retract, let's go ahead and take a look at that. I get the 200 thousandths to the clearance. But the thing is that when we're watching this tool diving towards the part, you know, from the last operation or whatever, it's not going to make that little deceleration pause at 1 inch. It's going right to 200. All right, so I think I can live with that. Mainly because the previous operations, it's going to be about the 200 range anyway, or the 1 inch range anyway. So don't know that that's that big of a concern. All right, so I mentioned the previous contour was going to go over to finish. So while I'm thinking about it, We come back over to Tool. There we go. And the roughing goes to Finish. And even though we didn't change anything, all right, so one of the things with just changing the comment, notice that it didn't go over to a dirty operation. It didn't see any change in parameters. All right, and then I'm going to copy and paste. And just a real quick reminder, the insertion arrow, wherever that arrow is at, when I hit paste, that's where it's going to put that operation, and then it's going to renumber accordingly. So there's times where the renumbering gets to be kind of, if I want to make a couple of changes, and I'm looking for operation 4 contour. After I do the insertion, operation 4 contour moves somewhere, and it's not in the exact same place, or it has the potential for not being in the exact same place. So that can be a little bit weird. All right, cut parameters. We're on the wall. So I hope I copied the right one. Gonna find out in a minute. Lead in, lead out. Nope, apparently I did not. So whichever one was checked, since I did that one last, and the indicator was that I didn't have that wall definition. So delete, yes. All right. So when I go to do the copy, I need to make sure that that folder is checked. Right? Otherwise, whatever folder is checked is what goes into the clipboard. That's what gets pasted. Okay, we copy, paste, and then now when I go to the parameters, I see the entry, the exit that I had. Come back, I turn the compensation off, and then again, just that little jog of memory. When I did the previous finishing, I don't remember going up and doing where. So as I'm going through, I'm error checking. And if it looks like I'm jumping around and I'm going back and forth, it's because I am. If I forget something, if I overlook something, I'm not concerned about it. Until it gets out to the machine, all I'm doing is cutting pixels on the screen. Do your double checks, do your rechecks, and at the very end when we post, I'm even reading through the code going, does that make sense? All right, so while I'm thinking about it, while it jogs the memory, we come back up to this one. We can go into where. If I've set the comments, I should see finish. I've got it. So even though I have a couple of dirty operations, we're telling it to regenerate all the dirty operations anyway. All right, so we're not really going to see that one unless I turn the displays off for those guys. Let's see, that was the ramp. And I think if that's the case, then the depth of cut was still on. All right, so we'll do one more check. Yep. So while I was thinking about where, I was ignoring the depth of cuts. All right, so we regenerate one more time. And which one am I displaying? There we go. All right, so we have that little loop in, comes down pretty close to the part, but off the wall, does the finish pass. Now we're ready to go on the other operations. Questions? All right, so if I stay Alt-7 at the isometric view, our pocket is going to be at 2 inches. So if I stay with the 3/4 inch tool, I'm going to have a little bit of material to remove. I can't just go on the contour and leave a boss in the center. Right? So let's go with the pocket routine. We'll have it open up, and then we'll see what we can do with the contour. The other thing, if I wanted to stay with the contour, if we did the ramp entry and then did the sidewall, now I can't think of it. Go back and double check here. The multi-passes, then there's still a possibility I could get it to do the same thing. But until you try these operations, you experiment with what works and what doesn't work for your machine. All I'm really trying to do is give you combinations that will achieve a desired result. All right, so let's go ahead and hide that one. We're going to stay with the pocket, but then we'll do a quick experiment with the contour. All right, so the chain, and we can go ahead and accept it. I want to double check the geometry. Pockets are always to the interior. This looks like it's going to be a conventional cut though. Right, so I'm the one always walking around with my finger in the air. If the tool's turning this way and I'm traveling this way, that's a conventional cut. All right, so in this case, I want to reverse the chain. All right, so reverse, and then on the interior, now I have a climb cut to machine with. Tool stays with the 3/4 inch. I think we'll be okay at the 4016. Still a little aggressive, but see what it does. Rapid retract, and this is going to be the pocket. I really got to turn the caps off. All right, so the cut parameters, standard pocket type. Don't really, unless it's a harder material, I don't usually leave material on the floors, and only a little material on the walls to come back and clean up, hold the tolerances. Again, you have to decide, are you going to rough and finish in this pocket operation, or are you going to have a separate? I think the separate, again, if I need more control, or if this is a bore that I'm going to have to fine tune, maybe I need something to be a slip fit in there, and I want to creep up on that wall slowly, so I'm going to stop the program and pick up that operation again. Then I definitely want it to be a separate operation, because this is going to be continuous. It's going to go right from the roughing, go find the wall, make the finish pass, and I don't want to run through the entire pocket again to hold that tight tolerance. If I don't, we have the 2-inch plus or minus 5, I'm probably going to be there. All right, and then the other thing is the familiarity with the tools. If you've used that tool enough that you can say from the touch off, from the start, that I'm going to go into compensation and subtract out like 2.5 or 3 thousandths, then we're going to be right there in the ballpark anyway. All right, so let's stay with the spiral. And 50% step over, even with it helical. Well, we got enough room. Let's go with the helical this time. We did the ramp last time. I think I would still prefer the ramp, but engaged. What do we say? Is that one? Oh, 3/4 an inch deep. So if we're going to go the full depth, if I do a step and repeat, then I'll probably go in 1/4 inch increments and take the larger step over. But if I go to full depth, then I'm going to reduce the radial engagement so that I increase the axial engagement. All right, so if I go depth, then I'm not going to go as much on the radius. And if I go lighter on the depths, then I can increase the radius. So it's always that balancing act of which do you prefer. Are you always machining with the last 1/4 inch of the tool, kind of rubbing that part of the tool, or do we want to use more of the flute length and be a little more consistent? All right, so if I'm going the full 3/4 inch deep, then I'll probably drop this down to maybe 100 thousandths. It's not that much over. We'll see what it does, and it's one we'll need to look at, see where we can pull up the machine times on the setup sheet, or the estimated. Entry motion, we're going to stay with the helix. Minimum radius, I like that to be a little bit smaller if it needs it, and the maximum radius of 0.75, it will probably do that. The only thing with the 0.75 is that it's kind of spinning around a point. There is the off chance that it leaves a little tower right in the middle. Not often, but it has possibilities. Let's see, center on entry point, follow the boundary. So that would be the other thing, is that if we center on the entry point, then it's pivoting around that single point. Usually it's going to come off of center just a little bit, and then when it makes that cut, if there is a tower there, it will remove it as it goes. So we'll see what we get in the simulation. Finish pass then, one finish pass, 10 thousandths on the wall, no spring passes. We're going to turn the wear on. and finishing just the outer boundary. Machine the finish passes only at the final depth. Even though we're not doing the depth cuts, we're going to helical in to depth. If I had the depth cuts on, I don't want it to finish at every step. And then machine finish passes after roughing all pockets. Don't really need to do that. Start finish pass at the close vicinity, and we'll keep the tool down. All right, so instead of doing a retract, picking up and going over to the lead-in point, it just feeds from wherever it finishes the pocket right to the lead-in. All right, so one less tool move that I have to worry about. There is that concern of I'm moving around in the bottom of the pocket, and I don't expect there to be any islands. I'm pretty much free to keep that tool down. If it looks like it's going to collide with anything, I'm going to have any issues, then I got to be a little more concerned with it. We're going to stay with the close, so maybe 100. 100, and we'll stay with the 90 degrees since it's interior. And then I'm just going to bring everything from the left over to the right so the entry matches the exit. We said no depth cuts, no breakthrough amounts, and we're right to the linking parameters, absolute, absolute, and absolute with a minus 0.75. And that retract still makes me a little nervous at 1/4 of an inch, so we'll raise it up a little bit. So the one thing with the helix is going to be that even at 3 degrees or whatever we had, that 200 thousandths could be anywhere from 3 to 5 circles in the air, and I don't want to cut any more air than I have to. So maybe we'll drop that to 50 thousandths, and I know it's going to do it. So if it pauses at the 1 inch, having it go to 50 thousandths, or if I was comfortable with the 250, having it slow up and do that pause before it makes the move to start the helix, I'm still okay with that, as long as I get that sense or that feeling of what it's going to generate. So that's an interesting move across the part to get to the start point. I don't know that that was exactly the closest, but we'll have to see what it does on the simulation. So it looks like it comes around, and then with the 100 thousandths, it starts at the middle. So let's see, if it's pivoting right at the center, that would be 1.5 inches. So we're kind of right there at the corner, and the material's already been removed. So let's go back to the roughing and do a little bit heavier and see if it still generates all that. So on the other side of that is, even with the ramp, if we end up with a little bit more, okay, so 2 less passes in the center, it's still going to clean up that floor before we start working out to the wall. And then it's only a couple passes out to the wall and the cleanup. All right, so that one would be a little bit of a concern. So, and at some point I should probably save this, since I don't want to do all this again. So A2, and I'll just save it in the default parts location. And we're ready to drill, and then we can start wrapping this up. All right, mill tool pass, and we're going to go over to the drill operations and the holes. We'll just pick to the centers. Okay. Let's see. We have arc 1, arc 2, arc 3. All C is a 1/2 inch. Use the highest Z depth, the lowest Z depth. All right, so if we're dealing with the wireframe, those are going to be referenced if we have geometry that is in the back, is lower than our top plane. The sorting is on the selected order, or we can go ahead and have it do the various zigzags. So that's a nice place to put that. And insert at the bottom of the list. So if we pick any additional 2D sort, rotary sort, cross sort, so they added a few things to that, or I didn't notice them before. So let's go ahead and accept. 4 holes, 4 locations, tool. So for the ream, we're going to filter to the drill bits, and okay. For a half-inch ream, I want to be about 484 to, what do we have? 484 it is. All right, so that gives me a 64th lower. Usually say the selection is going to be 5 to about 15 thousandths under, and then we'll pick up the reamer. All right, so 200 on the surface feet will give me an approximate, so 1577. Yeah, I can probably live with that one. And then the 4 thousandths per revolution, let's just make that a nice even 12. And this is going to be my pilot drill. I'm going to start leaving those. Okay, and then with the holder, we'd be more into a drill chuck. I got to go back and pick up the stock. It's not one that I use regularly, so next time we see this, I'll go back through the stock operations. And we want to do a G83 pec drill or G73 chip brake. All right, so this one's going to do the full retract. The chip brake is going to do a 5 or 10 thousandths retract and keep pecking. Yes.
How would you determine to do a ream operation without seeing tolerances on the print?
I want to add an additional operation, so it's one of those, again, it's optional. If you want to throw the reamer in there, it gives you another operation, since I don't, look at these and go, oh, half-inch hole's too easy. So if you put a half-inch drill in and you don't put a reamer in, I'm not going to be upset about it. All right, so if I stay with, I was going to do the pec drill. And 100 thousandths, that should be all right with the 484. Still have to be kind of conscious of the depth to diameter. So we're about, not quite 20%. And we're not doing anything with the axis controls, so that's new. I have a little reading to do on that one. Retractive half an inch. Let's make that 100 thousandths. Top of stock. Depth is to 2 inches. And then again, your choices were, I didn't have much luck with it on the center drill, is if we do the little calculator, then it will add in the 145. I'm not fond of that one. It makes more sense, or visually it makes more sense to me to come over to the tip comp. And even though it's adding the same value, I can kind of see the breakthrough amount so that the shoulder goes past that bottom depth. Or since we're going to the shoulder on a blind hole, then that just goes to 0. All right. Otherwise, we should be good, and we'll go ahead and accept. All right. So our 4 depths, and then since I didn't put a negative value in there, it rapids to the retract plane, and then it starts pecking above the part and pecks back to 200 thousandths. So whenever you see those lines above, we're going to react to it by coming back and making sure that I put the negative in. And okay. All right, so to make this now a ream, we're just going to copy it over, paste it. I'm not really worried about regenerating the dirty operation just yet. I'm going to close these guys up. And then on the parameters, we go back up to the tool, and we're going to see what we have available for the ream. So one of the things that is always a concern is the reamers have that lead chamfer, and it's going to vary between 20, 50, 60 thousandths depending on the size. So if I don't know that, or it's not in the library, then I'm going to have to grab the tool and measure. We're just going to guess and say it's about 60 thousandths. So that would be where I could go back to that breakthrough amount and said if the ream had to be 2 inches deep, then I would make the whole depth another, maybe 100 thousandths or so that I would have that clearance. All right, so we have a half-inch reamer, and I want to go ahead and take a look at it. So cutting diameter, cut length, amazingly enough, 2 inches. Chamfer distance of 0.625. So if we touch off and we go right to the bottom, I haven't left any room for chip pack-up or variation in the shoulder. If I pick 135 degree or 118, as long as, anyway, all of those little variations come to bear. All right, so our half the speed, twice the feed would put us about 800. And I don't know that I want to go right to 24, but I could see doing that at 20. All right, so we're going to get that tool loaded. And you know, the only downside is that we're going to have to make sure it gets plenty of coolant, plenty of lubrication. And then the cut parameters, we're going to go to bore with feed out. So instead of rapiding out, leaving the nice spiral down the pretty surface that we just created, it will reverse and come out at the same speed. Stop spindle and wrap it out. Well, have 6 nice little lines down the wall of your part, but we'll see. What is it? Fine bore. Yeah, so we have a couple of different options, and we can also dwell it at the bottom. Take a couple extra passes, make sure it cleans up. All right, so I said I'm going to look at the tool axis, the linking parameters, -2 inch. Tip comp, no. Well, if I have to, let's see, tip angle went to 170 or 180 degrees. So really need, if I'm going to hold this at the 2 inches, if that's critical, then I'm going to have to include that 063, I'll just round it, into the breakthrough. All right, so then that means I have to come back over to my pec drill and make sure that we said at least 1/8 of an inch. All right, and we'll go ahead and accept it. And now I can regenerate the dirty operations, see what it does. All right, so I won't generate the setup sheet since we're running a little bit long, but I do want to run the simulation. All right, and the 2 simulations were the back plot or the wireframe, and then the full simulation. So just in case, I'm going to save. And I thought that was just that was the save as. We're going to save. And I must have hit the wrong one. Simulator options, verify selected operations. Okay, there we go. I'll maximize it out. Well, it grew the stock a little bit, I guess, to match the fly cut. We shall see. Okay, that was a little fast. Performance, precision. Let's go ahead and slow it down a little bit. All right, so face cut. Yeah, I would say it added a little bit of material for us. We have the ramping. Ramping looks a little aggressive, but we don't have that much material. Take our step and repeats. Open up the pocket, drill, ring. Right. So again, if you want to add operations, you want to make it a tap, or you wanted to, I don't know, go a different way. If you would, run this till it gets to the base, that would be one other step. So I will point that out real quick. That if you wanted to ramp to the 1 inch to this first level, we would need to break this chain so that we can include those fillets, so that you would have a line segment, line segment, line segment. All right, and the way we would do that is come back over to the wireframe, break the entities, and then have a point at each of those endpoints of the fillet so that you could go all the way around. All right, so there's lots of what-if scenarios, lots of things that we could do. Pick your best and go for it.